I'm Glenn Canena. I'm the editor-in-chief at Nexmo, the Vonage API platform. And in this episode of Communications in Context, we are going to be talking about programmable voice, APIs, and Amazon Lex, kind of as building blocks for some real innovation around solutions that can connect customers with brands. And we're going to be speaking specifically to a team of engineering students from Princeton who use all of those tools to build a hack that won best use of a Vonage Nexmo API at the PennApps hackathon. Those team members are David Fan, Akash Levy, Zachary Liu, Selena Wong, and they'll be here to tell us all about how they developed the app and maybe what they plan to do with it now that they've actually completed this bit of innovation. And to represent Nexmo and Vonage in the conversation, we'll be joined also by Nexmo developer advocate and Alexa champion, Sam Machin, as well as software engineer on the Vonage Garage team, Kevin Alwell. So I'd like to kick off the discussion by just having the team, anyone can jump in, sort of describe what Lyft is. What is this project that you built? What does it do? What problem does it solve?
So Lyft is basically, it's a phone service that allows you to book a Lyft without access to the internet. Essentially, you call a phone number, and from there, it walks you through the process of ordering a Lyft to a street address, which you specify. It makes use of the Nexmo API, many Amazon services, and also the Lyft API in order to do this.
So I think in addition to what you mentioned, is that it's not only special because it books a ride for you, it's not just an application that books a ride for you, but it was built off a real use case, which is that Selena didn't have internet connection when she was looking for a ride, right? When she got off the bus 45 minutes away from PennApps. So you don't actually need an internet connection and you can still fulfill this ride request. So maybe you want to talk a little bit about that piece and how you specifically ended on why the voice is such an important piece of your hack.
It tends to emulate more of the traditional type of ways that we would order taxis. So taxi services in the past, you call a phone number, you order a taxi to a certain location, and then you can specify where you want to go. And this kind of enables that kind of service for legacy devices which aren't connected to the internet. Devices where you don't necessarily have access to the internet at all times, potentially in places where you have low coverage, for example, that this might be an extremely useful service for getting from point A to point B.
Yeah, it's really interesting because
what might be hard to understand for some people is the significance there is that we're taking the request through voice, right? We're mapping it to an online third-party service or a stream of them, which was the Amazon Lex. We're mapping it to the Lyft API, the Nexmo API is kind of passing it along and facilitating that connection there. And that's a really important piece that I definitely wanted to make sure we emphasize, because that was huge for us, obviously, as Nexmo, why you use that voice API. So
there's a surprising number of areas, even in really densely populated places, where you don't have coverage. So from personal experience in New York City this summer, a lot of times I didn't have coverage. It would have been helpful if I could call, or just call it, book a ride instead of walking to somewhere else to get better coverage.
So from our own personal experience, we've seen that even in highly populated areas, you tend to have these potentially problems with buildings blocking cell phone signals and things like that. And so in situations like that, it's easier to just look at your surroundings, find an address where you want to be picked up, and then communicate that in a different way.
I think one of the interesting things from my point of view with voice as well is compared to data. You say about that coverage, that usually once you've got a voice call up, it'll stay up, because when you make a voice call, you're kind of reserving a channel on the network for that call. So it's not like if you've got a weak data signal, you go, oh great, yeah, I've managed to find a ride, and then you can't complete the process, which is even more frustrating that it dies. Generally when a voice call, as long as you stay where you are, the capacity is guaranteed for the duration of that call once you've got through. So especially, even when we say about coverage, but in busy environments, like you're coming out of a concert or something and everybody's hitting the data network, and you're just trying to spread it thinner and thinner. Whereas if you can get your voice call through, you can complete the transaction and then get off the network and give it up. Sometimes it just doesn't doesn't really scale out well enough to cope with lots and lots of people all trying to make the same data requests.
And so I guess that poses an interesting question to the team, which is that what if I am coming out of a concert and trying to make that call and book a ride? How effective, I guess obviously you didn't build Lex, right, the NLP engine, but how much interference can it actually handle so that it books your ride accurately?
Yeah, we had some challenges with the accuracy of Lex, especially because we're going over a phone connection, which is not as high quality as, say, speaking directly to an app on your phone. But we did see that we were able to make some improvements to the Lex connector to improve the reliability of the recognition. And we do see that it is possible with some tweaks to have fairly reliable recognition, and we can also tweak the interface to confirm your location and to improve the experience.
Yeah, so that's a really great point that Zach made. A big component of our project was actually in building confirmations for this fulfillment task. Basically, a lot of the steps through the pipeline were basically confirming, hey, is this the address you want to go to? Basically saying, because we did notice that a lot of the times the address where we would put down would basically not be the same one as that the person was saying. So yeah, so I think that was a big piece.
The Google Maps API was really helpful with that, I'm sure.
Yeah,
Absolutely was.
So you guys were doing a geocoding on the input string, basically. So you were capturing in the Lex bot. Were you doing a what kind of slot were you using? Is there an address slot? I think within Lex, isn't there?
Yes, there is an address slot. So we were using an address slot and then mapping that with Google Maps geocoder.
So sort of to actually confirm that it's because obviously the slot just looks at the structure of an address. So then you give that to Google Maps and it'll actually make sure it is a real address.
Exactly.
Cool.
Yep.
So you guys were saying about the some of the tweaks you made to the Lex connector, and actually I'm looking at your pull request, which is really interesting. So because I wrote the Lex connector originally, and it started off as a bit of a hack project. So what's quite interesting is I think a lot of the stuff you guys were playing with was the timers. So some of those values as to short and long things, which was kind of makes sense. And I do wonder whether some of those timers almost like you set the timers for the specific scenario. So different interactions have maybe shorter or longer phrases. So you want shorter cutoffs, longer cutoffs, and tuning there. So one of the reasons I've been kind of looking at the stuff you guys have proposed and thinking, should we just sort of take these timers and make these the defaults, or should we be kind of making them more of a configurable parameter on so we'll have some defaults and then make it easy for you guys to just set them for what works for your app. So that's part of the reason why I haven't merged it yet, actually, is we're kind of looking at testing it on different cases. But the other one that you guys were talking about, the phone call, is quite interesting. So there is actually now an improvement to the Lex API to take what's called narrowband speech. So right now we kind of upscale it to 16 kilohertz and feed that in, which is more like the audio you get off your phone. But a phone call audio is only 8 kilohertz. So now Amazon have models for narrowband for 8 kilohertz. So hopefully as well with the next update we'll be able to support that, and it should give you better accuracy, because right now it's trying to sort of do high def accuracy on narrowband audio, whereas if you're now doing narrowband accuracy on narrowband audio, it should be a bit more accurate.
That's really cool. We were actually looking for a feature like that when we were building the hack, and we didn't see it. So that's really great to see that these improvements are being made.
Yeah. So no, we'll just downsample it before we go off to. It's quite easy because actually in the Nexmo API we're upsampling, so the call comes in off the phone network at 8 kilohertz typically. We upsample everything to 16 kilohertz because our core network and to the sort of best potential, because some stuff is 16 kilohertz, so internally everything runs at 16. But then right now, so we're passing out. So some of the tests I've been doing recently, we're going from 16 back down to 8. So really, actually undoing the upsampling that's being done in the network, so you're not losing any information because the original source was only 8 anyway. So you're just stripping out the stuff you're creating, and it's looking pretty promising. It's definitely more accuracy, and some other APIs I've been playing with, like the Google API, is a lot better at 8 kilohertz. So it was kind of interesting to see how that works.
Yeah, another big. I think Zach can talk more about this, but another big component of the thing we changed in the Lex connector was we added a more parallel model in that we added like multi-threading, and I think Zach, do you want to?
Yeah. I think one of the bugs we encountered was one of the bugs we encountered was a delay introduced by the cell network. there's maybe a half second to 1 second delay between when you say something and when the server receives it, and same in the reverse direction. And during that time, static and other background noise sometimes gets picked up as speech. So that's something we had to deal with, detecting when speech starts and stops, and also having that work well with the delay in the network, which is unique compared to, say, an app.
Totally. And kind of, it's one of the things with all these voice APIs is that most of the APIs are designed to work with like a mobile app or a hardware appliance, like an Echo or whatever like that. And those devices are doing very locally the kind of voice activity detection to work out when to capture audio or not. So you've got the initial capture and then the further exchanges. So obviously when you first invoke it, you capture audio until you get silence and then you send it. But it's those follow-up questions. And the problem with a phone call is that the audio is permanently open. So yeah, it's trying to figure out ways we can control the listening, so that we say, actually, yes, we're always listening, but just because there's audio there, only wait till we're kind of prompting for input for a follow-up question.
Exactly.
Yeah.
So that was kind of the big modification we made to the Lex connector.
Yeah, that's definitely one of the big challenges with voice recognition in general. I know that's one of the big areas of improvement is speech start and stop detection.
Yeah, and everyone thinks it's always about the wake word stuff in hardware, and oh great, yeah, we can wake it up and we can make it start listening, but actually it's easy enough to know when to start listening. It's harder to know when to stop listening, and especially if people put unnatural pauses in, because you're doing fairly crude sort of audio processing at that point. There's none of the machine learning and natural language processing really coming into play. You're just listening for sound. And at that point, you're thinking, well, is this the end of the speech, and am I processing a strange phrase, or that kind of stuff.
Yeah, you have none of the cues you get from speech. The computer's very brute force, knowing it's either on or off, either speech or not speech.
Yeah, it goes back to that whole thing that I remember hearing for years in kind of training stuff about how much communication is non-verbal and body language and gestures, and now it's all coming back into thinking, well, when we're talking to these assistants with speech, obviously all that body language and gesturing that we do as humans is completely lost. So we're trying to have natural human conversations, but with purely the verbal audio piece. Which is some really interesting challenges, I think, for the future of this stuff.
I'm actually just curious to hear from the team kind of how long this took you to put together. From the time Selena had that experience, recognized that was a problem that could be solved, from then until you submitted your hack, how long did that take?
We kind of came up with the idea late on, or around afternoon on Saturday, so I left us with about 12 hours to finish the hack. That's it. Or 20. Wait.
That's 24. Yeah.
24 hours. 24 hours. Sorry.
I'd say we came up with the idea around, like as David said, around 12 hours in, I would think, which gave us around 24 hours to build the whole the whole project. So we mostly started it on Saturday night, morning after we had like a full night of sleep. We kind of came up with the idea right before and like started working on it, but didn't really actually make too much progress before that. And then in the morning we got started on it in earnest.
So well, actually one thing I'd be quite interested to know is, like, I've done a lot of hackathons and things myself, and it's my hobby as well as my job now. But did you guys kind of find the technologies and the APIs and then kind of fit the use case, or did you think of the thing you wanted to build and then figure out, oh, how can we do this? What can we use? And we could use Lex, we could use the Lyft API, we could use Nexmo, that kind of stuff.
It was a combination, actually. So I think we were looking at both, like in terms of the APIs that were available at the hackathon. We were looking at those and thinking, which ones could we build a hack which would utilize these in a new, novel way that's useful. So we were kind of looking at that, and then we were looking specifically at kind of the. So I'd never seen Nexmo at a hackathon before, so I was looking into what their product did, and when I saw that, I was like, oh, there's so many cool use cases here, and then we started looking through the other APIs and thinking about how we could combine them. And then Selena's experience came in.
Yeah, when Akash mentioned this project, I was like, hey, that would have been pretty helpful just now. So yeah.
Yeah. So I guess maybe we could walk you through the timeline of how our project progressed. So yeah, I would say when we got there around
Say late Friday night.
Late Friday, and I'd say we spent most of the time at the beginning just thinking about different project ideas, brainstorming. I'd say we spent most of the first night, Friday night, thinking about ideas and just exploring. Like, we kind of went through most of a lot of the API websites and looked at those. Yeah.
And we spent even on Saturday, we spent a lot of time experimenting with the APIs and learning how to use them. This was like the first time most of us had used Lex, first time most of us had used Nexmo and Amazon services. So we spending a lot of time figuring out how to use these services, and learning what their capabilities were and their limitations were was also a huge chunk of our time.
Yeah, around like really late on Saturday / like 3 a.m. on Sunday, we were trying to fix the race conditions in the Nexmo in the connector, and then we fixed it like maybe an hour before the submission deadline.
Yeah. Yeah, so I think it helped a little bit that I'd had some experience with Amazon Alexa ahead of time, which isn't the same as Amazon Lex, but it generally relies on similar technologies. So we used Lex basically to do most of the voice processing and taking it through the process of booking a Lyft. I don't think any of us had used the Lyft API before, but we actually found it very easy to use. And Zach actually took some time to reverse engineer the process of logging into a Lyft in order to book it. Zach, do you want to talk about that a little?
Yeah. So the Lyft API was primarily designed for a use case on a mobile app where you can launch a browser and have the user log themselves in. But our use case was pretty unique that we can only recognize things by voice. So we realized that the Lyft API the Lyft website allows you to log in using a code that's sent to you by text message, but this was not exposed through the API. So we did some reverse engineering to see what the requests the website made while it was sending these codes and receiving the codes in the backend, and integrated that into our hack. So we did a little bit of reverse engineering to figure that out.
Yeah, and so that was a pretty big piece of the hack. In terms of productionizing it, we'd want to, we'd potentially want to work with Lyft in order to get correct access to this type of API, potentially through other means. Yeah, and I think that was a really big piece, was just kind of figuring out how we wanted to make this work. I think our hack was more complete than I was expecting it to be by the end. We had essentially all the pieces that we needed for it to be productionized there. Well, the final steps that I think that would need to take this project from just being a hackathon project to production is kind of we would want to make a better stateful. So we actually another thing that we implemented was a stateful kind of the call is basically stateful. So you can hang up and pick it back up, and then you can go back to where you left off. And I think that's a really useful feature in the case where you don't have you have kind of spotty coverage. This will help you pick up the process where you left off, and I think that's really important for the kind of the purpose that we built this for.
And I guess also we would have to maybe give the user more information about the card, so maybe like the license plate number or something.
Yeah, and other than that, I think towards the end, so we actually never tested our project on an actual Lyft. We were using the Sandbox API, which is basically, you can see it basically allows you to book a Lyft in the development mode, so it doesn't actually contact their servers and make requests that you don't want. So we didn't actually test that. But there would generally be more information we'd want to give to a user about, like where they're being picked up, how many minutes away the ride is, what the license plate number is, what the car looks like, something like that. That kind of information we'd want to communicate to the user in a better way. Mm-hmm. We didn't have much time at the end. This was something we would have added on later. When productionizing, this would definitely be an important thing to add in.
The way, like, obviously Lyft, one of the big use cases, so Lyft use us as a customer of ours right now, because all the phone calls, obviously you've got the piece of booking, typically you book your ride via the app, but then the communication with the driver is still done over a phone call or a text message normally. And I think there's some really interesting kind of scope there for integrating the two. So actually, if you're in the phone call, you can, from that phone call, it can then transfer you to your driver maybe or something. So you're already on a call and it books the Lyft, and with deeper integration, because people right now are switching between an app experience and a phone call experience anyway. So if they're going to start off in a phone call experience, then let's make it a single one.
Yeah, I 100% agree, Sam. I think with deeper Lyft integration, this would be a fairly simple feature to add, and definitely making use of some of the more intricate Nexmo APIs with doing voice proxying. I think that the call proxying, we actually looked into that while we were doing the project. We explored that API a little bit. We couldn't really figure out how to integrate that with our project, but that definitely would be, if we had cooperation of Lyft, that could definitely be a further.
Right now, you actually need access to the real driver's phone number, not the number that we give the app, which is a proxy number, because
that would be on the Lyft side a little bit more, but it would be very cool.
So interestingly, I was just thinking about this, like this use case. Everything today, people are doing in apps. We're ordering our dry cleaning, we're ordering pizza, and do you think that there's the same model would work for other things as Lyft as well? So actually, we could build more of these bots on phone calls to access services as a complete alternative to the mobile apps for services. Anything you've thought of like that?
Absolutely. I think it's very good to have a backup in the case that there's something goes wrong with our internet connections. There's no guarantee of reliability 100% of the time. And in the cases like that, I think our phone services tend to be more reliable generally than our internet services do. And even today, and hopefully we should see that these kind of services are used as a backup and not as the main service, because it generally tends to be quicker and easier to use an app in most contexts. But as you said, I think it would be very nice to have kind of a phone service in the back end, like as a backup solution for
but I think
a lot of
especially
these
now with things like the sort of AI bot platforms being able to sit there as a back end, it means that companies that whereas running a phone service, actually answering a phone and taking orders was really expensive for a restaurant or something traditionally, because it was quite time consuming, whereas somebody can place their order slowly online and browse and surf and things, and then boom, it just sends a little printout or a little message to the restaurant that says here's your food order or whatever. So I guess using bots now, we can get all the benefits of doing something kind of automatically for the business, but the consumer can still have that voice interaction if that's what they want. Or you don't want to install an app for everything. Like I order a pizza maybe once a month. I don't want to have an app on my phone that I'm going to use once a month. I just want to have a number saved in my phone book.
Mm-hmm. And I think also optimizing the voice experience also unlocks a few new markets and new potential applications. You mentioned voice bots, but also for those for the blind who can't use an app in the traditional apps, this also unlocks new potential. You can use voice to request a ride and interact with other apps in a purely voice way. So, along with that, and also seeing ways that you can, so streamlining the voice experience definitely.
And accessibility, isn't it?
Mm-hmm. Yeah.
Absolutely.
Especially, I have a question for Kevin. So you were on the other side of this at the actual PennApps hackathon and saw this as a submission, and the Vonage Garage team had actually already built kind of a bot that used SMS to accomplish similar things. So I'm just wondering about the day of reviewing their submission and what kind of set them apart, and then maybe talk a little bit about the similarities between what they built and the CatBot.
Sure. So there were a lot of similarities. From a high level, it's actually very much the same as what we built for the CatBot. We ended up using different services because what we actually built, just to kind of fill in the team here, is a text-based, so using the Nexmo SMS, a text-based way to fulfill ride requests. And rather than using Lex, we use something called API AI, which is Google's NLP platform. And something that stood out to me when I spoke with you at the hackathon, obviously I thought it was a genius idea because I had the same idea myself, right? No, I'm just kidding. But I thought it was a really great idea. But what really stood out to me was the engineering potential of your team, because not only did you identify a problem and develop a solution, but you did that without even though you faced challenges in what you tried to pull into your application, the tools. So what you did was you actually created a new tool, or you modified the tools that you had at your disposal to make your app work. And so I know for myself and the other judges, that was a really huge thing, because obviously there are other hacks that use the same API, the voice API or the SMS API, but that really stood out to me. And I think it was a hack well done.
I think that goes to show the power of open source, even with a corporation like Vonage. By having their tools be open source, the community, people working on projects using their APIs can contribute back and find new ways to use a product that the company may not have even encountered.
Yeah, absolutely. I think the fact that the Lex connector was open source was what enabled us to really make a working product. In the end, like, we were able to tune it to our own needs of the product, and actually that was what enabled the kind of call quality that allowed us to make our product work.
Yeah, absolutely. And I guess that kind of speaks, at least in part, to the value of having open source projects, right, for companies, because while we do have great resources internally, obviously Sam is exceptional and his team is exceptional. Sometimes it just helps to have other people working on completely separate use cases, and that pulls in that other thought of, hey, maybe we can expand in this direction. And ultimately the company benefits and the consumer benefits, because it allows them to have the foundation, which is what Sam built, the Lex connector there, but also to build on top of it for their specific use case.
I think that was kind of a big thing that, like we say, when it's all very new stuff, this, and this idea of interacting with these voice platforms. So we don't, we played around, we built it, but we didn't know we got it right necessarily. So part of the reason to open source it is that, like you say, you guys can improve it, can tweak it. It's still really a development. I mean, we call the Lex connector a beta product anyway, on the docs and things. So we have the hosted version really to get people started quickly, but all the different models of how people are going to interact and how people are going to use it. Also, it's being able to improve it, but also being able to extend on this stuff. We're a developer platform. We're here. We give you stuff to build with.
It's impossible as a developer to think of every possible use case.
Absolutely. Yeah. We don't know how people are going to want to use things. So the more flexibility, and it really is a balancing act between providing enough utility and value and giving you something that you can get working with quickly, but also then you can mold and shape and tweak and change the bits you want to change without having to kind of start from a completely blank sheet. And yeah, open source is really the kind of the model of that. But of course, I think a lot of companies see it as either commercial or open source, whereas we can provide a commercial service and we can provide a managed service for you and we'll run it, or you can just take it and use it and you're still using it with our service. So it's we kind of win both ways, but I think that is really useful.
Yeah, I guess that kind of brings up a really another question, which is that how did the team come across the Lex connector? How did you come across it during your hackathon?
So
was it in the documentation, or?
Yeah, it was. We were looking through the Nexmo API, and we were looking specifically for chatbot functionality. And we were looking, and we saw the Lex connector, and we thought, oh, this is like exactly what we want. And it was especially good for me, having used Amazon Alexa before. The Lex kind of provides a similar framework to the Amazon Alexa framework. And so there was kind of it was a little bit easy to transfer my knowledge from one area to the other. I worked on mostly the Lex aspects of it, yeah.
And how did you feel about the documentation for Nexmo overall, as far as launching your account, creating a number, finding the number, hooking up the webhooks and everything? How was that overall experience?
All of that was documented very well. I think the Lex connector in particular was a little bit tricky to set up and get that connected, but it's a new product. It's completely understandable.
Sure.
I mean, sometimes it just happens to be the nature of the functionality, right? That it's not so trivial, such as if you're sending an SMS, all you have to do is input the number in the message, right? But there's other considerations.
Yeah, but setting up the number, getting all that stuff set up was fairly straightforward. We were pretty impressed.
Did you guys try the hosted version? So we run it in two modes. We have the hosted and then we have it as open source. So did you initially kind of try the hosted one to do the sort of hello world level stuff and then fork it?
Yeah, we actually did use the hosted version originally, the one that's hosted on the the Nexmo side, and that's where we started seeing some of the issues that were for our specific use case. And then Zach started looking into that. He spent a couple hours diving into what the problems might be and going and making an actual fix for that.
Yeah, it was very helpful having the hosted version, and especially having the copy-paste samples available in the documentation, because it let us try out the service and immediately verify that this was going to work for a use case. And only once we hit some limitations, and then we branched off into our own custom version. But having the hosted version there available to use is very helpful.
That's really good to hear, because it's a bit of a new model for us for doing these things, or certainly these middleware connectors as we're expanding out the platform. And I think it is the right kind of approach, and the end goal will be to have it kind of as fully productized and deep integration as possible, but we'll still want to probably keep the open source option there. So it's trying to understand that developer journey of, you say you want that quick, easy discoverability and testing, because you don't want to spend hours spinning up servers and building code to find that it isn't suitable, but you need a test drive, don't you, really, to know that it's in the right space and it's worth pursuing.
Absolutely. Also, we built it incrementally, so kind of our initial solution was just saying, just doing data input and then sending it back to us. So that's kind of our sanity check. And once we got that working, that was we were like, woo! And that's how we knew that we could actually take this forward and build it into a full product. So it's good to see that initial, the first time we called the number that we bought, and we're like, it actually said, "Hello, welcome to Amazon Lex," and then we were like, "Oh, this is really great." So yeah.
So hey guys, I'm actually interested in any kind of burning questions you may have specifically about the connector, or maybe even more in general for Sam, seeing that he's kind of the architect of the tool, just based on your experience.
Yeah. Do you? What is the how commonly is it used right now, and do you know what the specific other use cases might be for it?
Okay, so yeah, so who's using, or how much use and who's using Lex? The interesting answer is we don't necessarily know exactly who's using it, because we're a platform and it's self-service. So we're seeing traffic on it, certainly on the hosted version, and then when we get out to the run your own version, it's open source. This is one of the trade-offs. You don't really know exactly what people are doing with it. But it's predominantly in the sort of customer service. The use cases, certainly the questions. I mean, mainly what I see is when people ask me questions on our Slack forum and things. And most people are doing something they're using it to sort of sit in front of their call center or their existing telephony service and offload some of that traffic. So, you call a number, and the first person you speak to is the Lex bot, and they kind of ask it the basic questions. What are your opening hours? Or I want to check something's in stock. And then they transfer the call over. So one of the big use cases, really, I think that we haven't properly, or we can make even easier. Right now, you have to do a bit more work. Is the idea of talking to a bot, and then the bot deciding who to transfer you, or where to transfer your call to a sort of real human operator. And it's this hybrid approach rather than the pure, I just want to speak to a bot. I think, in that way, your hack is probably more unique. It's maybe 20% of the scenarios are pure bot, and 80% are a hybrid bot human way of working. I guess there's the other one that is kind of, there's a lot of interesting startups. There's a couple in New York actually that I've spoken to who are doing AI assistant. So it's not so much you call a bot, but the bot makes calls on behalf of you to the services. I want to cancel my gym membership. You have the assistant call the gym and negotiate with the gym to cancel your membership for you, so you don't have to make those kind of calls. And people are actually offloading tasks that they don't want to do and calls that they don't want to have to make to bots to make the call for them, which is very interesting.
That is very interesting. Never even considered that possibility.
So, yeah, I mean the whole model works both inbound and outbound. It's a little bit odd, I guess, if you're a regular kind of person on a front desk at a company or something, and you get a phone call and then it's from a bot, and you're going to think it's marketing, but it's getting there. There's a few scenarios like that, and eventually we'll just get to a world where it's bots calling bots and talking to each other, probably.
Like, does it actually work though? Like that company's product?
Yeah, there are a couple of companies out there that are doing virtual PAs, not massively in the voice. Most of them are experimenting with voice. There's been a couple of them around with email recently. That's like you can CC in this virtual assistant into your emails and say, oh yeah, set up a meeting with Fred on Monday, and then the assistant takes over the email conversation. And companies like that are now experimenting with adding voice. So what we're seeing is they're going, oh, okay, we know people, and people are paying hundreds of dollars a month for these assistants, these bots, to just organize your meetings for you. So there's definitely, and it seems a lot. A couple of $100 a month seems a lot for a bot, but you look at the cost of hiring a full-time PA or an assistant, and it's bringing it down there. So I don't think I'm not quite yet senior enough to afford to employ myself a virtual assistant. But
I had a question about the development of the Lex connector. Did you work directly with Amazon in building this connector, and what was the level of collaboration between Nexmo and Amazon?
Yeah, so I guess mostly we got Vonage, so I got access to the Lex beta, or whenever it was they call it. It was announced at reInvent last year, and it was in like a private developer preview or whatever it is. They can't remember what they call it exactly. So I got onto that preview, so I had access to the docs. But predominantly, I built it in isolation just from reverse engineering their docs. Again, like you guys, I've done a lot of stuff with Alexa, and especially a lot of the hacking I've done with Alexa has been the Alexa voice service. So I built a Raspberry Pi based Alexa device and a web based one and some stuff there. So I was kind of, again, familiar with what I'd done with Alexa and voice processing, and obviously I was familiar with the Nexmo WebSocket, so I was like, I could put these two together. So their SDKs were really just like assuming you were always going to embed your bot into an iOS or an Android app as your access channel. And there wasn't really, there was some documentation for how you talk to the audio API on its own, the post-content endpoint. The authentication took a lot of guesswork because that really wasn't documented. It was just, just sign your response, but you can't sign a binary payload. So that was a couple of days of just changing things and poking and seeing what worked. But the first version was pretty much totally reverse engineered from some preview docs. And then since then we've been having conversations with them, and obviously they really like the use case. They've got customers that are asking to be able to put Lex on phone calls. So hopefully, we'll have that. I've had a couple of meetings with the team in Seattle and stuff about it. So
maybe we can close on this question unless anyone has any other items I'd like to discuss with each other. But I'm kind of interested in thinking about Lyft. If it were a product and you're looking at the product roadmap and version 2.0 and so on, sort of where would you imagine taking this given time, given resources? And I'm actually interested in the team's answer and just Kevin or Sam also, when they're thinking about this as a starting point, where could you take this?
Absolutely. So I think we've been talking about this a little bit. So in terms of Lyft itself, I think there are a few things we could do in terms of improving the ease of use for the user. And we would definitely need to complete it, make sure that the stateful events are working properly, things like that, and also could upgrade the call quality now that I know that is fixed. So those would be things that we could do, like cosmetic fixes mostly. But I think in terms of moving beyond that, I think we would actually want to work with Lyft. Possibly, if we were to take this to the next level, we could talk with Lyft, potentially integrate this with their own Lyft types of service. As Sam was saying earlier, we could directly do call proxying with the driver, which would be really nice. I think that would be a really great use of Nexmo's API. And potentially, even in the future, we could extend this kind of idea to apply to other types of services, other types of automating things, like perhaps Uber, for example, or other things where the APIs enable this type of service. Zach, do you have any thoughts?
Yeah, actually, I think integration with Lyft would be the best way for our hack to make the most impact because Lyft already has so many users. I think it'd be really cool if, like, the Lyft app could detect if you have like a weak connection, and they could be like,
Direct you to a phone call.
"Hey, like, yeah, do you want to book through a phone call instead?"
Yeah, that's a really good
Again.
point. Yeah, so Selena was saying that basically in the app, actually, I think it already does do sort of a weak signal detection. And in that case, it could actually recommend calling the phone number. Yeah.
Yeah, exactly.
Yeah, so it's basically it's the error page, isn't it? It's like the 404 page or whatever. It goes, sorry, there's a problem because the request is timed out or something. So yeah, you now have that kind of process of all you've got to do is go from that error handling scenario to offering the voice option as a fallback. It's really good. I think you're right. You know, it is definitely something that it's a great hack and it's a really cool hack. But you know, you could never productize it outside of Lyft necessarily because what's in it for you guys, really? You know, you're going to pay money to run a server so that Lyft can make more money. So really, it would have to be a sort of thing you would sell these whatever, provide to them, and it's in their interest to run it. I think we said before, you know, the idea though that this is not a unique use case, the Lyft API. There are hundreds of companies out there, and even the really small stuff, particularly food restaurants, pizza places, the single shop that don't have the resources, the market to have an app, but these guys, you know, so if you can build a repeatable framework and turn out these bots for them, then for you guys on their own, you know, as a team standalone, as not part of a bigger company, I think there's an interesting opportunity there to produce more and more of these bots directly for people who don't have an app or don't want an app or just want to have that kind of simple scenario and say, oh yeah, hey, we just deliver the order to you to a tablet that lives behind the counter on a kind of email type message or something.
And to build on that point, Sam, oftentimes when we do a hackathon, for everyone who's done a hackathon here, you know that you have a propensity to kind of just throw out your hack and move forward from there, right? But what I would do is I would definitely encourage you to kind of pay it forward to people who are going to be hacking on something similar in the future. And if you could open source what you have developed, or maybe share a blog post or something that shares the information on the architecture and how you built what you built. And this way, someone who starts in the future can start from where you left off, right? And that's how we kind of build up from there. So in the future, we might be having a conversation on the other side of the table where you're talking about your connector, you know, and how someone built on that.
Yeah, I think you guys, you certainly your fork of the connector is open source. I didn't see. Did you actually publish the Lex bot code as well, or are you keeping that one for now?
Yes, actually. So on our GitHub repository, we have the entire code base available, and in the README, we have a section on how to set up. So I don't know exactly how to export a Lex project. It's all on the website. So I've taken screenshots of everything that you need in order to set it up and gone through detailed instructions. Basically, I recreated the entire Lex project and made a step-by-step procedure for doing that. Since I wasn't sure how to export the project.
Shall receive, huh?
Yeah.
That's one of the problems I think with a lot of these tools right now is traditionally we wrote code and we had this big bundle zip file with all our code and our resources and everything in it, and we could just deploy it, whereas these sort of platform assistants, you have a lot more models and configuration that's all put in via a kind of a GUI, or you're setting up different things. It's not just a bundle of data that you can upload yet, at least. I mean, some of them have got sort of APIs. And
I was a little surprised. I thought that there might be some like sort of Lex configuration file that you could download and upload and things like that. It looks like they haven't really gone that far with the service yet. I mean, Lex is also a fairly new service. I'm sure that they will get to that at some point.
I think there is now, I don't know if it was even launched, but there is a Lex, they've got a skill creation API or bot creation API now. And there certainly is for Alexa. So one of the things that released about a month ago or so for Alexa was the skill management API in the command line tool. So now you can do it all from a command line, which means you can have a single build folder that says you define your JSON model, interaction model in JSON and your utterances and all of that, and then you just sort of type it's ASK deploy or whatever, and it pushes it up there. And I think I have seen some stuff for Lex. It's actually a while since I've looked at the bot side of Lex, so I'm gonna have to go back and see. But yeah, it's getting there. It's definitely the tooling around all of this stuff is the companies are shipping the product first, and because obviously they want to get the thing out there, and then when they're figuring out how people are using it and what the stumbling blocks are, that's when the tooling tends to come along and improve things. Lex is really it's only been out of developer preview 6 months, I think. So it was announced at reInvent last year, so it's just up to 12 months old, and I think it was about April, May time it went public. So it's a very new technology, I think, and it's a very new model. It's not like anything that's kind of come before in a lot of it, is it? So
yeah, I agree. Ultimately, I could see the goal being, as Zach was saying earlier, this could definitely be very good for vision impaired people, where it might be difficult to interact with an app directly. And I could see a whole suite of these kinds of services being built around different apps that we have on our phones.
I had a question for Vonage and Nexmo. What excites you to do about hackathons, and what motivates you to go to hackathons? Like, what's the biggest value you see coming out of these events?
So we partner, generally the HR team kind of leads the charge on the Vonage side. I know Nexmo has the DevRel team, and that's what that's where Sam comes from. But from the Vonage side, it's all about driving awareness for talent in the area. So for talented people like you, talented engineers like you, we love to have you experimenting with our tools, improving our tools, such as you did with the open source repo. We love to get out there and see what the newest technology is that people are looking to expose themselves to. Because at these hackathons, a lot of times, I know myself, I'll go out there and not realize some of the different use cases and how important machine learning, NLP, AI is becoming. And all the possibilities. I mean, some of the use cases that come out of these hackathons are just phenomenal. So so we love to get exposed to the talent. We love to hear what it is that you're working on, what you think is important, kind of pull those ideas back into the organization. And if we can, obviously invite people like you to come back and join us and just kind of driving Vonage and driving our mission, which is to be at the forefront and be innovative always. And challenging the status quo.
So yeah, totally. For us, like the thing with hackathons, Nexmo, the bit where the Nexmo side of the business sort of differs from the traditional Vonage side is that Vonage tend to sell products to businesses and more of an end finished. They're a product company, and we sell building blocks to developers. We sell more of a raw material that people will use to build products, and potentially Vonage can use the Nexmo products. So mainly for us, I guess. One of the things that we do hackathons, we don't normally go to a hackathon expecting to recruit our next big customer. We're not. It's great, and we never know that you may get somebody who starts a project at a hackathon, builds on top of our API, and gets a bunch of VC funding the next day, and kind of suddenly is the next Uber or whatever. But that's really quite a unique scenario. Really, for us, one of the great things about hackathons though is the product feedback. So as a developer relations team, we actually sit within product in Vonage rather than sales or marketing or even engineering. And it's because we're really pushing forward the product. And we know that at a hackathon, you're going to get kind of the best testing, pushing, stressing in a very intense product feedback and testing scenario that you wouldn't get in a sort of normal sales, marketing, development cycle with customers. So you guys are kind of showing us what things to do with the product, and like you say, you guys have already fed back improvements, and that's fabulous. And we get some great stories out of it like this, but also we get the use of the product and the education and the stuff you guys are trying to do, and the things, the limitations maybe that you hit up against in a hackathon where the pressure's on. We can go back and fix those or improve the experience there, so that when the big customers come along on at a later date, it's a better experience there. So really that's kind of our main focus of hackathons.
So thank you again to our guests for a great conversation. Team Lyft, that's David Fan, Akash Levy, Zachary Liu, and Selena Wong, as well as Nexmo developer advocate and Alexa champion Sam Machin, and software engineer from the Vonage Garage team, Kevin Alwell. This has been Communications in Context. I'm Glenn Canena, and we'll see you next time. Thanks.